Right, so moving on, we're going to find the multiplication of polynomials. Now, the multiplication of polynomials uses a property which is known as the distributive property. Now, distribute means to share each and every item of the first polynomial over each and every item of the second polynomial. And so if I have two polynomials, p of x and q of x, where p of x is giving us ax squared plus b, and q of x is giving us c plus b f plus fx to the power 3. Then to multiply p of x by q of x means distribute each and every item of the first polynomial, which is p of x, over each and every member of the second polynomial, which is q of x. So this becomes ax to the power squared plus b times c plus fx to the power 3. And so the first term of the first polynomial multiplies each and every term of the second polynomial. And then the second term of the first polynomial multiplies each and every term of the second polynomial. And so if you pick the first term of the first polynomial, which is ax squared, it multiplies the whole of the second polynomial, which is c plus fx cubed. Then we pick the second term, which is the plus b, multiplies each and every term of the second polynomial, which is c plus fx cubed. Now we have ax squared times c, that will give us ac s squared. Then ax squared times fx to the power 3 will give us af x to the power 5 plus b times c will give us bc. B times fx to the power 3 will give us bfx to the power 3. So let's look at real examples. If you have p of x giving us 5 minus 3x squared, and then q of x giving us 2x squared plus 1, then p of x times q of x will be the first polynomial, which is 5 minus 3x squared, times second polynomial, which is 2x squared plus 1. So multiplication uses the distributive property. It means multiply each and every term of the first polynomial by each and every term of the second polynomial. So we pick the first term of the first polynomial, which is a 5, and multiply by the second polynomial, which is 2x squared plus 1. Pick the second term of the first polynomial, which is a minus 3x squared, multiply by each and every term of the second polynomial, which is 2x squared plus 1. Now 5 times 2x squared will give us 10x squared. 5 times 1 will give us 5. We move on to the second part. Minus 3x squared times 2x squared will give us minus 6x to the power 4. Then minus 3x squared times 1 will give us minus 3x squared. Now we notice that there are some like terms in here, which is the 10x squared and then the minus 3x squared. We can put these things together. So minus 10x squared minus 3x squared will give us 7x squared. The 5 has no other like terms, so we have plus the 5. The x to the power 4th term has no other term like that, so we write it down just like that. Now you can either leave your answer in this form or leave it in descending order. If you're leaving it in the descending order, then it means your first term becomes minus 6x to the power 4 plus 7x to the power 5, then plus 5. And that is how you find the product of polynomials. Now the next thing that we want to find is known as the zeros of a polynomial. Finding the zeros of a polynomial or the roots of the polynomial or solution of the polynomial, they all mean the same thing. It simply means that equate your polynomial to 0 and find the value of the variable in your polynomial. And so if I have a polynomial p of x, then to find the zeros of the polynomial, it means equate p of x to 0 and find the value of your variable x in the polynomial. So we'll start with the simplest one, when the degree n is equal to 0. If the degree is equal to 0, such a polynomial, or such an expression is known as a constant polynomial. An example was when p of x is given as 6, or when p of x is given as -2/3. There's no variable in our polynomial, or the degree of such a polynomial is 0. Therefore, such a polynomial is known as a constant polynomial. Now, to find the zeros or the roots or the solution means equate it to 0 and solve for x. Equate it to 0 and solve for x. Now, if I have 6 is equal to 0, what is the value of x? First of all, there is no x in here for you to find. And so the solution or the answer to such a question is there is no solution. If you have -2/3 is equal to 0, what is the solution to such a problem? There is no solution. And so if n is the degree and m is the number of solutions to the problem, then it means that if the degree is 0, then the number of solutions to the problem is 0, because 1, there is no solution. So if there is no solution and I'm to count the number of solutions to such a problem, then I'll count 0 solutions, right? So example, if I have p of x given as p -3, to find the 0 means equate it to 0 and solve for x. What is the solution to the problem? There is no solution. Therefore, my m, which is the total number of solutions to the problem, is 0. So when n is equal to 0, my m is equal to 0. Now, if my n is equal to 1, then what kind of polynomial do we have? A linear polynomial. An example is if I have p of x is given as 2x minus 3. It is linear because the highest exponent is 1. To find the zeros means equate it to 0 and then solve for x. To solve for x, take the constant term to the right hand side of the equality sign. So we have 2x is equal to 3. Now we're looking for x, not 2x. So divide this side by 2, this side by 2, and we have x is equal to 3/2. Now, how many answers are we counting here? Only one. There's only one x. Therefore, m is equal to 1. And so we notice a general trend here. When my n is equal to 0, which is when the degree is 0, the number of solutions m is equal to 0. There's no solution. When the degree is equal to 1, the total number of solutions we are calling m is equal to 1. Therefore, if the degree is equal to a, then the total number of solutions will also be equal to a. So in effect, if I have a polynomial of degree n, then the total number of solutions that polynomial will have is also equal to n. Not n repeated solutions, not n distinct solutions, but n solutions. Right? So they could be repeated, they could be distinct, but at least there has to be n solutions, where n represents the degree of the polynomial.